Hi, so we're ready to look at section 2.3, which is additional displays of quantitative data. So in section 2.2, we looked at some of the popular displays with quantitative data, so we look at some others. The first one we're going to look at is stem and leaf plots. So a stem and leaf plot is just another way to represent quantitative data graphically. So in a stem and leaf plot, or sometimes called a stem plot, you're going to use the digits to the left of the rightmost digit to form what's called the stem, and then each rightmost digit is going to form what's called a leaf. Right, and there's some directions here from the text on the steps to construct a stem and leaf plot. Right, so I'm going to go through example with you. So example one is we want to use this data set. So I have it posted on Canvas as 2_3_table15.csv, and then also it's listed right here below. So I want to do this by hand, and then also try to do this in StatCrunch. So first thing we want to do is make like a legend. So for this data, right, what makes sense is to do 1 and then a line 1 is going to represent the number 11, right, as an example. So if you notice, these numbers, they range from 11 as the min, and the maximum is 48, I believe, right? And again, if you're ever unsure, how we could do this quickly, I have this data in StatCrunch. I could sort the data. You can see 11 is the smallest value, and 48 is the largest. So in other words, when I construct my stems, I'm going to want 1, 2, 3, and 4 as my options. I'm going to draw a line to separate the stems and the leaves. And then it's actually helpful to do this when the numbers are in order. Excuse me. So I think it makes sense to look at it from here. So we have 2 11s, right? So if you would open up the data and sort it like I did, it might be easier to follow along. So we have 2 11s, and then we have a 12, and then 2 13s, and then 2 15s. So notice I'm drawing essentially the ones digit, right? So in this case, on this side, this is the tens digit. And on this side, we're showing the ones digit for each of the data sets. Right? So then there's 116, 317, so I need to draw 3 7s. And then 1, 2, 3, 4 18s. And then 2 19s. Right, and then now we're into the 20s, so we have 120, 121, 2 22s, 2 23s, 3 24s, so I need to draw 3 4s, and then a 126, 2 27s, 2 29s. Then now we're into 30, so there's 130, 131, 232, so I need to draw 2 2s, 136, 137, and 138. Right? And then I have a 46 and a 48. So this represents a stem and leaf plot. And the idea is if you draw each number like the same kind of width and you have like the same spacing in between them, it's basically like a histogram on its side, right? Where like these are the bars, right, if you will, like the length of the numbers. So they show like a distribution shape, right? So if you turn that on the side, you'll notice that looks to be like a right skew distribution, right? Right, so if you want to do this on StatCrunch, so I have the data listed here, what you're going to do is you'll go to Graph and then Stem and Leaf Plot. All right, we'll select Data, and my leaf is the ones unit, right? So I just need to select 1. And then hit Compute. And that should be the same thing that we had gotten. Right. One thing that's different is they decided to split the each stem in half. Right. We're going to talk about that in example 2, actually with this same data set. So in other words, the range from 10 to 19 will become 10 to 14 and 10 or 15 to 19, right? So that's what was done here, and this is what we're going to construct in example 2. I don't know if I don't think there's an easy way to change that in StatCrunch. It chooses that automatically, like the bends, right? Right. So with example 2, we're going to construct each stem into 2 stems. Right, so we'd have 2 1s listed, 2 2s, 2 3s, and 2 4s. And then we still need a legend. So the legend is that 1/1 represents the number 11, right? So in other words, for this first one, as I was saying, we're going to think about this as the numbers 10 to 14. And then this this one will be the numbers 15 to 19, right? So in other words, this first one, we're going to let the ones digit be between 0 and 4. And then for the second one that shows up, we'll let the ones digit be 5 through 9. And you'll do that for each of those. Right? So what you should have is we got 2 11s, a 12, 2 13s. Right? So I could show this up here. Right? So if I mark it in blue, that's going to go to the second line, right? So like this part would all go down the second line. This part would, this would, and this would go everything in blue would go to the second one. Right? So if we transform that, this is what you would get. Let's see, 0 1 2 2 3 3 3 4s, and then this would be 6 7 7 9 9, and then 0 1 2 2, and then 6 7 8, and then there'd be nothing listed here, and then 6 8. Right, so that just changes my bin width, or my class width, from 10 now down to 5, right? Now I just showed you how to do this in StatCrunch, and it automatically picked that. Right. So just like a histogram, there's no, there's no right or correct, stem and leaf plot. They're both correct, but remember, some of them can be more useful than others. Right. Right. So then now, example 3, I want to look at an example where we have continuous data to do a stem and leaf plot. So if you remember this data set, unemployment, which I have here. These are unemployment rates by state, and we have all of these are like have decimals in them, right? Or most of them. So it goes all the way to just the tenths decimal spot, right? So just one decimal spot beyond, right? So remember, the leaf in your stem and leaf is always going to be the rightmost value, right? So like in this case, this 8 is going to be the leaf, and the rest of it's the stem, right? So when we make a legend for this, right, we're going to want 2/4 to represent 2.4. Right, so this doesn't mean 24, it means 2.4. So that's why it's important to build a legend, so that way you know how to interpret those values. So then now, if I go back to my data set, right, remember what would be really helpful is to put this in order, so I can sort this, and then now I can go through and write in my stem and leaf plot, right? So it's correct to when you're doing the stem and leaf plot, like here, that we're listing these values, these leaves, in order, right, in numerical order. So my possible stems are 2 through 8. Right, and I know that because when I sorted this, the minimum rate is 2.4 and the maximum is 8.4. Right, we actually found those values in the last section with this data set when we were calculating the class width. Right. So if you want to have that data set open and sorted, I think it will be easier to follow along again. So what this one will looking like, so we have two 2.4s, right? So I want to draw 2 4s here, and then I have 2.5, actually two 2.5, so I have 2 5s, and then I have a 2.7, and then 3 2.8s, and then a 2.9, right? So I'm just going through and drawing all of these. So if you want to pause the video here and fill it in, and then unpause it, and you can check how you did. Right, so that's what you should get for the stem and leaf plot, and you'll notice this distribution shape also looks to be right skewed, right, where we have like a big part towards the left and then like a long tail towards the right, right? So let me maybe draw that a little more dramatic, right? So maybe more like that, right? So that's right skewed. Or we can call it positively skewed. Right, so another name for right skewed is positively skewed, and another name for left skewed is negatively skewed. So then now, with example 4, we're given the stem and leaf plot and trying to go backwards to get the data set, right? So if we build this, right, so this 0 indicates the value 10, right? And we can tell from the legend that 1/0 represents the number 10. And then so this one would represent 11, this number would be 14, right? So each of these values on the leaves is going to be a number, right? A data number, right? So you want to pull those apart, right? So this one here would be 21, and then we'd have 24, and then another 24 because there's 2 4s listed and so forth, right? So go ahead and pause the video and you can check yourself on this one as well. Right, so this is the data set that you should get for number 5. Right? Well, example 4, but it's, I think, number 5 in this section, right? So then now what I would like to do is look at example 5, which is just an example of what we call back-to-back stem and leaf plot. So what you'll notice is the stem here is in the center, and then we have leaves on either side, and each side represents something else, right? And it's a way for us to compare like two different values, right? Like two different things. So here we're comparing McDonald's with Burger King. So I want you to take this back-to-back stem plot and determine the original set of data again, right? Just to make sure you understand what this represents. So, we could list Burger King and then come up with that data set. So this number 7 here would correspond with 7, right? And again, you're going to make sure you understand the legend. So this is pulling apart where the stem is the tens value and the leaf are the ones value. So then we go to Burger King. So we got 2 2s here, so that would be 2 12s, and then 1 3 would be a 13, and then and 16, 2 16s, 17, so forth, right? So I'll finish writing the Burger King in a moment, so you can check yourself. But let me get you started. Make sure you understand the McDonald's as well. So with the McDonald's data set, right? This 8 would start with the number 8, right? And then that 9 here, right beside it, would be the number 9. And then this 0 with this 1 corresponds at 10, and then 12, 14, 2 16s, 17, 18, 19, right? So that's going through everything with a stem of 1, right? So you would keep going and get all those. So pause the video now and fill those in, and you can check yourself. Alright, so you can check yourself with the Burger King and McDonald's original data set, and that's what you should get for those solutions, right? So now you should be able to make sense of a back-to-back stem and leaf plot. So the next thing that we want to look at is the frequency polygons, right? So I have some terms here to denote. So a class midpoint is the sum of consecutive lower limits divided by 2, right? So remember what the lower class limits are, right? So if you have classes like, let's say, 10 to 14, and then 15 to 19, right, and so forth, and then like 20 to 24. Remember that these values here are the lower class limits, where these values here are the upper class limits, right? So we want consecutive means, 2 classes right in the same order, right? So to calculate the class midpoint, you would take 10 plus 15 and then divide by 2 to get this class midpoint, and so forth. So a frequency polygon is a graph that uses points connected by line segments to represent the frequencies for the classes. It's constructed by plotting a point above each class midpoint on a horizontal axis at a height equal to the frequency of the class. Next, line segments are drawn connecting consecutive points, and then 2 additional line segments are drawn from connecting each end of the graph with the horizontal axis. Right, so if you go to page 96 in the textbook, they have here an example that you could read over about calculating those, right? So it makes a little more sense. So like, this first class, is 50 to 74.99. So to find the class midpoint, remember we take the two consecutive lower class limits, so that'd be 50, and then the next lower limit 75. Basically, you're averaging those two values, right? Finding the midpoint. So you take 50 plus 75 divided by 2, and you get 62.5. And then there's one frequency value for that, right? So you're going to do that all the way down, right? You should be able to calculate frequency and relative frequency for the classes, okay? The kind of the new part here is calculating these class midpoints, right? And then if you go here to the next page, what you'll notice is what's plotted are these class midpoints along with their frequencies, right? So the x-axis, the x-coordinate is going to be these class midpoints, right? So this is your x-axis, and the frequency is your y-axis. If you want to have a frequency polygon, right? So, so the next example I have is not constructing a frequency polygon, but answering some questions about it, which will help us go a little deeper with it. So it says the following frequency polygon represents the cumulative grade point average of a random sample of students at an engineering school, right? So you can see the frequency polygon graph there, and the title is what is your cumulative grade point average. So part A says what is the class width? How many classes are represented in the classes, right? So one way to calculate the class width is to subtract the midpoints, right? If you subtract the midpoint values, that's also going to give you the class width. So if I take 1.25 and subtract off 0.75, we get 0.5, right? So the class width is 0.5. And then to find the number of classes, what we're going to do is take the number of dots and subtract 2, right? And the reason why we subtract 2 is because if you remember from the definition of a frequency polygon, you're going to add in 2 dots, right? We're going to add in this dot and this dot when we draw this diagram in. So then if you count, I have 1, 2, 3, 4, 5, 6, 7, 8 dots. So we take 8 minus 2 to get 6, right? So we have 6 classes, and the class width is 0.5. And then so the next questions go a little deeper in the graph. So part B says, what is the midpoint of the first class, right? Well, the first class is the second dot, right? Because remember that first dot we added in. So the midpoint of the first class is this x value, which is 1.25. Right, so that answers the first question. And then it says, what are the lower and upper limits of the first class, right? So what you want to do is take the class width 0.5 and divide it by 2, and that gives me 0.25, right? So in other words, I need to add and subtract 0.25 to 1.25 in order to find these lower and upper limits, right? We're like working backwards. So if I take 1.25 plus minus 0.25, what I end up getting are the values 1 and 1.5, right? Right, so in other words, what I'm trying to show here is that 1.25 minus 0.25 is equal to 1, and 1.25 plus 0.25 is 1.5, right? So then the lower and upper limits, right, or what that interval would look like would be, 1 to 1.49, or more specifically, we could show an interval notation, which would be 1 to 1.5, where we're including 1 but excluding 1.5. Right, because 1.5 would be into the next class. So then part C is very similar. We're looking at the midpoint of the last class. So the last class would be this guy, right? The second to last dot. Because remember the first and the last dots on here we added in. So the midpoint of the last class would be 3.75. And you're going to do the same thing. We're going to take 3.75, subtract 0.5, and take 3.75 and add 0.5. Right, in order to get those values, right? And you might be wondering, why did I take the class width and divide by 2, right? Because if you think about it, like here's a number line, right? Maybe between here and here represents the class width. Right down the center is going to be where the midpoint is, right? So what I want to do is take this class width, this distance, divide it by 2, because that will tell me each of these parts, right? Because what I'm after is trying to find these two tick mark locations, right, like on a number line. So hopefully that visual makes more sense to why we're doing that. So then, if you take 3.75 minus 0.2, minus 0.25, right? Oops, and this should be 0.25, not 0.5, right? 0.25, 0.25, right? Just like before. I just wrote down the wrong value. So 3.75 minus 0.25 is 3.5. And 3.75 plus 0.25 is the value 4. So the interval that we're looking for would be 3.5 to 4, including 3.5 but excluding 4, right? Or in other words, 3.5 all the way until we get to like 3.99, right, and so forth. So as close to 4 as we can, but not including 4, right? And we can get closer than 3.99. Just sometimes that's how it's listed to mean that we're trying to get really close, right? And then so part D, it says what are the lower and upper limits for the class with 25 students, right? So to find 25 students, we'd be looking for the frequency that matches up with 25, which would be this value here, and that has a midpoint of 2.75, right? So the midpoint is 2.75, and it doesn't ask that, but we need to know that to calculate this. You would take 2.75 minus 0.25 and 2.75 plus 0.25, just like before, and get 2.5 here and 3 here. So we'd be looking for the interval from 2.5 to 3, including 2.5, excluding 3, or in other words, like 2.5 to 2.999, so forth, right? Trying to get as close as we can to 3 without equaling 3. Right? So then part E is what are the lower and upper limits of the class with the fewest students. Right? So we'd be looking up here. Let me erase things on here. So remember that these two dots are not classes, so I'm looking for what's the class that has the fewest number of students. So the dot that's closest to the x-axis is going to be that value, 1.25. Right? So then we already did this work, right? This would be, the same as part B. Right, the solution, same as part B. So the midpoint for this is 1.25. So then the interval would be 1 to 1.5, just like we found above. Right? All right, now we're ready to look at objective 3. So objective 3, we're going to look at a different way to display quantitative data. We're going to look at cumulative frequency and cumulative relative frequency tables. So a cumulative frequency distribution is going to display the aggregate frequency of the category. In other words, for discrete data, it displays the total number of observations less than or equal to the category. So it's like a running count, right? And then for continuous data, it's going to display the total number of observations less than or equal to the upper class limit of a class. And then a cumulative relative frequency distribution is going to display the proportion or percentage of observations less than or equal to the category for discrete data, and the proportion or percentage of observations less than or equal to the upper class limit of a class for continuous data. Right? So, if we want to create a cumulative frequency like in example 7 using the unemployment data, right? We can go through that and show you how that's calculated, right? So I'm going to use the classes, like how StatCrunch calculates this. So I think it makes it a little easier. So just as a reminder from last section, so we were looking at, this data set. If I go to stats, tables, and frequency, right, I want to look at the rate, and I'm going to leave frequency and relative frequency here selected and hit compute. And then remember, this is telling me that we should do some binning, right, because there's a lot of individual values. We say yes, and here is the frequency table distribution that StatCrunch automatically does, right? So it's recommending that we do 2 to 3 as my classes, right? So I want to use those same values here for the classes. But if I go to options and hit edit, you'll notice there were some other options here in the statistics. So I can hold down control on a PC or Mac. If you have a Mac, you can hold down the command key, and I can hit cumulative frequency and also cumulative relative frequency, right? Those were the two things that we were adding in. And if I hit compute, and I want to hit OK for continue the binning, and I want to go over with what these numbers mean now, right? So, like if I look in this first row, first class, the cumulative frequency is 9, and here the cumulative relative frequency is 0.17, right? So then how do we get this 32 number? Well, that's going to add these two frequencies together, right? 23 plus 9 is the number 32, right? Same thing with this cumulative relative frequency. It's adding that relative frequency and all the previous relative frequencies, right? So then if I look at, like, where did this 51 come from, right? That came from taking 1 plus 3 plus 15 plus 23 plus 9. So you start with that frequency and then add together all the previous frequencies, right? And same thing with the cumulative relative frequency. You're going to look at this this value, this value here for the relative frequency, and then add up all the previous ones, right? And that's going to give you this number here, right? And of course, in your last class, it makes sense for the cumulative relative frequency to be 1, right? Because that would represent all of the data, right? So that number should always be 1, and then this cumulative frequency here should match your count, right? Total number of items. Right, so that's how you make a cumulative frequency distribution and a cumulative relative frequency distribution. So then objective 4, we want to construct a frequency and relative frequency ogive, which is using using that distribution table that we just did in example 7, right? So it's just a graphical representation of that. So an ogive is a graph that represents the cumulative frequency or cumulative relative frequency for the class. It is constructed by plotting points whose x-coordinates are the upper class limits and whose y-coordinates are the cumulative frequencies or cumulative relative frequencies of the class. Then line segments are drawn connecting consecutive points. An additional line segment is drawn connecting the first point to the horizontal axis at a location representing the upper limit of the class that would precede the first class if it existed. Right. So let me show you how to do that. Right, so if I pull back that table from StatCrunch, right, this table, if we first want to create just a cumulative frequency ogive, the values, these second values listed here for the rates, those are going to be your x coordinates, right? So the 3, 4, 5, 6, 7, 9. Also, we would have 8, but it would just be unchanged. And then next you would you would have the y coordinate, which would be the cumulative frequencies, right? So in other words, using that data as a guide, right, to get your points, we can make an XYT chart. Right, so I'm going to list, so the first one would be 3, and we're going to do the cumulative frequency. So it would be 3, 9, and then 4, 32, and then 5, 47, and then 6, 50, and then 7, 51, and then 8 would also be 51, right? There's no values for that. And then 9, 52. And then don't forget, what you have to do is you pick what the, if there were a class before the 2 to 3, what would be the ending value, and that would be 2. And then you set that equal to 0 for the y coordinate, so that way it's on the x-axis, right? So those were the directions that we had just read over. So if I make a graph here, I can just list 1 through 9, and this would be the unemployment rate. And then over here we would have cumulative frequency. And then I'll go up by 5s. We need to go up to roughly like 50, 55, I think. Oops. I wanted to write 50. Should be 30, 35, 40, 45, 50, 55. And then if you want to give a title, we could say, January 2019 unemployment rate by state. Right? So then we just plot these points that we just listed here. Right? So we got the point 20. I'll do that in a different color. So we have 20, and then 39, and then 432, and then 547, and then 650, and then 751, 851, and 952. Oops, that should be more in line with that guy. All right, and then next, you're just going to draw lines connecting the dots, right? So line segments connecting each of the dots. Right, and then so that would represent an ogive. Right? Then if you want to create one of these in StatCrunch, pull this over. Right, what you're going to have to do is, we want to create like these ordered pair points for its graph. So I'm just going to take this, and I'll put it on my other monitor so I can read it, but you could fill in. I'm just going to type in x here and y here for variable 5. And then I'll list here, we have 2, 3, 4, 5, 6, 7, 8, 9. And then for the y values, we had 0, 9, 32, 47, 50, 51, 51, 52. Right? And then so now what I can do is go to graph and then go to scatter plot. And then for the x variable, that would be x. The y variable would be y, what we named y. And then next, see, I think we just need to pick to display the lines, right? Display the points and the lines. So I just hold down Control to select both, and then we could add x-axis, y-axis labels like we did. So I could say unemployment rate as a percent along the x-axis. Along the y-axis was cumulative frequency. And the title of the graph I left be January 2019 unemployment rates by state. Right, so then I can hit compute, and that should give me that graph, which it did. Right. All right, so then the next type of graph to look at with quantitative data is a time series graph, right? So a time series plot is obtained by plotting the time in which the variable is measured on the horizontal axis and the corresponding value of the variable on the vertical axis. And then line segments are drawn connecting these points, right? And something we'll find, like in example 9, is that it's common to have, comparing multiple like different groups over time can be helpful. So in this case, we're trying to identify trends in the data over time. So we're considering the data set of death rates, so which is the number of deaths per 100,000 in the population. And that's pretty common, like if you're in the medical field, for death and other types of rates to always be per 100,000 in the population. And then, the reason why we're trying to compare everything to 100,000 in the population is so that way, groups that have less people in them are better accounted for, right? So like, for example, right now we're in a COVID pandemic. If you look at the COVID cases, typically, like the county numbers, typically that's shown as per 100,000 residents, right? So like if I just search for the COVID Ohio County data, you can get the COVID-19 dashboard. Oops. And then so if I pick a county, let's see. Yeah, I thought it would be. I think this is the wrong website. I was looking for the color county county level data. I think. Right. Yeah, this looks right. Right. So notice here, like Franklin County is all automatically shown, and it says cases per 100K, which is 100,000, right? So it just gives us a common base to compare the different counties from. Like for example, if we compare the number of just the number of cases in Franklin County versus like Marion County or Morrow County, that's not really fair, right? There's a lot more people that live in Franklin County compared to Marion or Morrow, so it's more likely that Franklin County is going to have more values, right? Even if 50% of Marion County had COVID, those numbers probably aren't going to compare to Franklin's, even if it's just like 10% or something, right? So that's why it's not really fair to compare those just straight values. Right, so like looking at this, there's not going to be the same number of people in non-Hispanic black group, the non-Hispanic white group, and the Hispanic group. So we want to put them in common terms, so we're putting them deaths per 100,000 in the population and plotting those over time, and you can see the trends. So when we have some questions, so like the first question is, which ethnicity has the lowest death rate? So the answer to that would be the Hispanic group, right? Because that graph is below all the others the entire time, right? So this first question here would be Hispanic, and then Then the next question says, which ethnicity experienced the greatest decrease in death since 2000, right? So this starts at 2000 and ends at 2017, right? So we want to see what has the biggest drop, right? And just to point out something too, right? This is a line break, right? Just another version instead of the line with the dash bars on it like that, right? So I showed you that before last video, but this is also a type of line break, right? Because we're going from 0 to 800, which would be going up by 800 every time, but then we're adding 200 each time, right? So remember, we have to have that constant interval, but that just signifies to the reader that we're cutting out that blank white space, right? Because if you imagine all of this, if we didn't cut that out and do a line break, this part of the graph would just be up here, and then we'd have this big block of white space here. So it's just trying to get rid of that, right? So what we're looking for is like these horizontal distance essentially, right? So like, for the first grouping, there's like the max to min values essentially, right? So let's say maybe that's at 1700, and this value is roughly 1400. So that distance between the two is roughly 300 per 100,000 deaths, right? And then if you look at the non-Hispanic, that's at roughly maybe 1300 down to 1200. So there's maybe only like 100 difference between the biggest and smallest values there, and then here we're going 100 down to maybe like, I don't know, like 850 or something like that. So that's maybe like a distance of 150 roughly. So in other words, it's real easy to see that this top group, top category, is going to have the biggest decrease in death rate, right? So the answer to that last question would be the non-Hispanic blacks. Oops. Right. So then now, now what I would like to do is create a time series plot for the birth rate data on Canvas, and this data is also shown here. So if I pull in StatCrunch, and this tab is the data, right, that I have posted, and what you're going to do is go to Graph and then should be scatter plot. And then my x variable is going to be year. My y variable is going to be birth rate. And then we're going to want to select display points and the lines. All right, so hold down Control and click that. And then you can add in labels here. So this would be, year for the x-axis. The y-axis is going to be the birth rate. And then a title for this, would be birth rates per 1,000 women aged 10 to 49. All right, then I could hit compute, and we can get that graph, right? And we can see that it's really decreased over time, right, dramatically, right? All right, so that's all I have for this section. So we have just one more section left in chapter 2, and then we can start into chapter 3, right? So let me know if you have any questions. Thanks.